From finding water on the moon's surface to nano antenna made from DNA, these are some of the stories that we talk about on this episode of Scientifics. I am Mohana Basu, and every week on ThePrint Scientifics, I take you through some of the top science stories of the week from across the globe. For the first time, data from China's Chang'e lander has provided evidence of in situ detection of water on the moon. While several orbital observations and sample measurements, including those from India's own Chandrayaan mission completed over the past decade, have presented evidence for the presence of water, no in situ measurements have ever been conducted on the lunar surface. The Chang'e spacecraft brought back 1,731 grams of lunar samples from the moon. Before sampling and returning the lunar soil, however, the Lunar Mineralogical Spectrometer on board the lander performed spectral reflectance measurements of the regolith and of a rock, thereby providing unprecedented opportunity to detect lunar surface water. The quantitative spectral analysis indicates that the lunar soil at the landing site contains less than 120 parts per million of water. This is consistent with the preliminary analysis of the returned Chang'e 5 samples. Meanwhile, scientists from the University of Cambridge have reassessed a human fossil and found that it dates back to over 230,000 years ago. The findings push back the date on which our species is first thought to have evolved in Africa. The age of the oldest fossils in Eastern Africa, widely recognized as representing our species, Homo sapiens, has long been uncertain. The remains known as Omo-1 were found in Ethiopia in late 1960s, and scientists have been attempting to date them precisely ever since. They do this by using the chemical fingerprints of volcanic ash layers found above and below the sediments in which the fossils were found. Earlier attempts to date the fossils suggest that they were less than 200,000 years old, but the new research shows that they must be older than a colossal volcanic eruption that took place 230,000 years ago. The region where Omo-1 remains were found is an area of high volcanic activity and a rich source of early human remains and artifacts such as stone tools. By dating the layers of volcanic ash above and below where the archaeological and fossil remains are found, scientists identified Omo-1 as the earliest evidence of our species, Homo sapiens. Also this week, scientists have found the world's largest fish breeding area known to date, located in Antarctica's Weddell Sea. A towed camera system photographed and filmed thousands of nests of ice fish of the species Neopagitopsis iona on the seabed. The density of the nests and the size of the entire breeding area suggests a total number of about 60 million ice fish breeding at the time of observation. These findings provide support for the establishment of a marine protected area in the Atlantic sector of the Southern Ocean. Researchers viewed numerous fish nests on the monitors aboard the German research vessel Polarstern, which their towed camera system transmitted live to the vessel from the seabed 535 to 420 meters below the ship from the seafloor of the Antarctic Weddell Sea. Evaluation showed that there were on average one breeding site per 3 square meters, with the team even finding a maximum of 1 to 2 active nests per square meter. The mapping of the area suggests a total extent of 240 square kilometers. Extrapolated to this area size, the total number of fish nests was estimated to be about 60 million. Based on the images, the team was able to clearly identify the round fish nests about 15 centimeters deep and 75 centimeters in diameter, which were made distinct from the otherwise muddy seabed by round central area of small stones. Meanwhile, researchers from the University of Bern and University of Geneva have discovered an exoplanet, WASP 103b, that resembles a rugby ball rather than a sphere. Due to strong tidal forces, the appearance of the planet WASP 103b resembles a rugby ball rather than a sphere. This is the first time that researchers have detected the deformation of an exoplanet. On the Earth's course, the tide determines the rhythm of events. At low tide, boats remain on land. At high tide, the way out to sea is cleared for them again. On Earth, the tides are mainly generated by the moon. Its gravitational pull causes an accumulation of water in the ocean region below, which is then missing in surrounding regions and thus accounts for a low tide. Although this deformation of the ocean causes striking differences in level in many places, it is hardly recognizable from space. On the planet WASP 103b, tides are much more extreme. The planet orbits its stars in just one day and is deformed by the strong tidal forces so drastically that its appearance resembles a rugby ball. The planet is located in the constellation Hercules and is almost twice the size of Jupiter, has 1.5 times its mass, and is about 50 times closer to its star than Earth is to the Sun. Also this week, researchers from the University of Montreal have created a nano antenna to monitor the motions of proteins. This device is made of DNA. The new method to monitor the structural change of proteins over time can help scientists better understand natural and human-designed nanotechnologies. The team is currently working on setting up a startup company to commercialize and make this nano antenna available to most researchers and the pharmaceutical industry. Inspired by the Lego-like properties of DNA with building blocks that are typically 20,000 times smaller than a human hair, the team created a DNA-based fluorescent nano antenna that can help characterize the function of proteins. Like a two-way radio that can both receive and transmit radio waves, the fluorescent nano antenna receives light in one color or wavelength depending on the protein movement it senses, then transmits light back in another color which scientists can then detect. One of the main innovations of this nano antenna is that the receiver part of the antenna is also employed to sense the molecular surface of the protein studied via molecular interaction. This is Mohana Basu, special correspondent at ThePrint. If you like our work, do consider paying for a subscription to ThePrint. You can do so through the link in the description box below.